Hey everyone, in this video we will start the chapter on inequalities. Basically that's a chapter that's found in A Math, H1 and H2 Math. Alright, so this is just an introductory video where we're talking about like notation and whatever that is very basic. Okay, so let's get right to it. So first of all we have notation, and I think the first things that should come to your mind would be the inequality symbols, right? The very simple ones, basically your lesser than and greater than, or your lesser than and equals to, or the greater than and equals to. So these set notations, right, you've probably seen them a lot. So let's say we have x less than 3, or x is greater than equals to 4, or sometimes you have double ends, right? So x lesser than, x greater than 1, or lesser than and equals to 4, all right? So these notations, right, it's actually your range, all right? So these solutions are basically your range, all right? The ones on the far right. However, in the H2 Math syllabus, you'll learn something else, right? You also learn that, hey, you can also represent this in terms of set notation. All right, now set notation only deals with brackets. So you have two types of bracket, curved brackets and square brackets, all right? So what does this mean? So if you look at your brackets, right, there's a left and a right. So on the left is basically your lower limit. On the right, you have your upper limit. Same thing for the square bracket, all right? So what is the difference between them? So your curved brackets, basically these are your less than or equals to. So these are your non-inclusive. Okay, your square brackets are inclusive. Okay, so basically they're the same, right? They're basically these two and these two respectively. So how do we actually use them? So let's say we have the same ranges, right? X less than 3. So we're not including 3, therefore if they use set notation, the lower limit will simply be negative infinity, right? You cannot have any number because it stretches always to negative infinity. And you cannot include infinity itself because infinity is a concept, it's not an actual idea. Then to 3, which is not inclusive, therefore it's curve minus infinity. 2, 3, close curve bracket. For x equals to or greater than 4, we then simply have the lower limit, inclusive of the lower limit, 4, infinity, which will be a closed curve bracket because you cannot include infinity. Let's say we have x greater than 1 or less than or equals to 4. So we have a curve bracket 1, close bracket 4, square bracket 4. Okay? So this is how we use set notation. Another part on set notation is that if you want to represent, let's say, the ranges in terms of proper set notation. So let's say the set of values, right? So these, the ones on top is called the range of values. The next one I'm going to show you is called by the set of values. Okay. So a few ways to do it. One way is basically include the range of values. So what you do, curly bracket. So x is any real number. Okay, let's say we have x less than 3 as an example. X is an element of the real numbers. We have x less than 3. All right. You can use comma or on the absolute sign, absolute value signs, but they mean the same thing. Alternatively, you can say that x is an element of the real numbers, where we have x is basically, let's say, minus infinity to 3. Okay. So two ways to put it, but do be careful, right? For the H2 Math students, if they ask you for the set of values, you need to use this notation where you have the curly brackets and indicate that x is part of the reals. Another part in our inequality is actually your number line, okay? So for the A Math, H1, and in fact sometimes H2 syllabus, you'll see that the number line you could use like this, right? So let's say we use x less than 3, all right? And x bigger than or equals to 4. So we have 3 here, then we have 4 here. Okay, then because number lines increase on the left to right, we can add any values on the left, but they must be less than 3 or less than 4. Okay, so do be careful. All right, now let's say we want to denote the solutions of x less than 3, right? So we can use an arrow because there's nothing more efficient, so we use an arrow on a number line. But here comes the ambiguity, right? Do we include 3 or not? To solve that ambiguity, we add a empty circle to denote that we do not include. So this basically means x is less than 3. For x greater than or equals to 4, we use another arrow, But because now we're including it, what we do, we add a shaded circle. All right, so just remember, shaded means include. Empty circle would mean not include. So there we have it, x greater than 4. For H2 math students, another number line that you will be using, where we have, let's say, values A, values B, where A is less than B, and these values A and B are called your critical values. Crit values, where the values either make FA or FB, causes it to become 0 or undefined. All right. So this, you only see this in your, sometimes your algebraic, or sometimes even in your ln functions, but usually algebraic. All right, so two conditions where FA or FB equals to 0 or undefined, right? Could be FA equals to 0 and FB be undefined, but whatever the case is, you are actually able to actually show that in your number line. Again, right, instead of using arrows, we'll use the number line to actually show what the values of fx would be. So let's say we're looking at fx, right? Let's say that from a all the way to the negative infinity, the function becomes positive. Therefore, we indicate with a plus sign to indicate that the function gives us a positive value for all real number less than a. Let's say from a to b, we have minus. From b onwards, we have plus. All right. Now, here's another ambiguity, right? Do we include a or b or not? Because we know that these values a and b would cause the function to either be 0 or undefined. So it's very simple. If we cause the function to be undefined, we will denote it with an empty set. So from here, we know that fa is undefined. All right. If we use a shaded circle, we would know that fb equals to 0. Okay. So it's a very important notation, because sometimes if you're going to find, let's say, fx greater than or equals to 0, then you need to include the value of b. If they just say that fx is bigger than 0, then you don't need to include the value b. All right. So basically, the idea is that the signs would denote the function, whether is it positive from what range to what range, or negative from what range to what range, and the range would be dependent on the critical values that would cause either the function to give you back 0 or be undefined. So there we have it, the introduction of inequalities.